Good morning and welcome to our live event. Thanks for joining us today as we share some insights into why combustion matters.
And really, more importantly, why good combustion matters and the effects of poor combustion and how it impacts your business.
So we'd like to share with you some insights that our PSNERGY team has gained over the past 10 years as we've worked with customers throughout the country to help them improve furnace performance.
And it's important to note that it doesn't matter the size of the operation nor the size of the furnace. Everything that we're going to talk about can be applied to customers in big steel and aluminum, captive and commercial heat treating, and primary metals processing. So the one thing that they all have in common is that most of their products go through an industrial furnace at least once, whether that's an open fire or radiant tube furnace, maybe a batch furnace, or even a continuous furnace.
Right. So if most of what you sell to a customer goes through a furnace, stick around for the next few minutes and learn why good combustion matters, as well as the effects of poor combustion on your business. I think it's important to note that we're not going to really talk about products or services or technology at all today. Our goal is that everyone listening in makes the connection between combustion performance, furnace performance, and business performance. And we're talking about performance in all aspects, including safety, quality, delivery, and cost.
If you have any questions throughout the presentation, feel free to just enter them into the comment section and we'll get to them at the end of the presentation. So let's get into it. Heat treating can be complex, but fundamentally it's relatively straightforward. You make energy with your combustion process and you transfer that energy to the products inside your furnace. So if what you sell goes through a furnace, you basically get paid to transfer energy from the furnace to those products. And transferring energy out of your combustion system and into the product is what defines furnace performance. So ultimately, furnace performance has a direct impact on business performance. So you might be wondering, what is good combustion and what is poor combustion, and how can you see it?
Simply, good combustion is the right combination of air and fuel that delivers the most heat output with the least amount of emissions. So take a look at the graph here. This is showing excess oxygen along the x-axis. This is the oxygen that's left in the exhaust stream after combustion's taken place. And percent oxygen in the exhaust is really a great indicator of combustion performance. The red line is the amount of carbon monoxide being produced through combustion. The yellow line is the heat output from combustion. And as you can see, as we approach 2% excess oxygen, which is the blue line on the graph, the amount of CO being released is minimized and the heat output is maximized. And this is just purely chemistry.
So theoretically, you would want to operate the process at a 10-to-1 air to fuel ratio, which would result in 2% excess oxygen. And that means that all of the fuel, usually in most cases it's natural gas molecules, would find enough oxygen molecules and combust, leaving extra oxygen in the exhaust.
Yeah, and that works really well in ideal conditions. However, what we've experienced is that in industrial environments where equipment is not brand new, filters may not always be clean, running at those ideal conditions actually puts the process at risk of going rich. And going rich means having fuel molecules that have not found the oxygen molecule partners to combust with, which results in making carbon monoxide, and it also results in making much less heat output. The one thing we know for sure, combustion systems work at very high temperatures and they're constantly degrading. So leaving room for air is really a good idea, which is why the industry standard is to operate closer to an 11.5-to-1 ratio, which results in that 3% excess oxygen in the exhaust. And that's shown as the green line on the graph. Now, what happens when we operate combustion rich or below that 2% excess oxygen level? Emissions increase and heat output decreases. And you can see from the graph, the amount of CO produced rises very quickly as you approach 0% excess oxygen. And when you get to 0%, there are actually raw fuel molecules that are not being combusted at all.
So it's great that you can see it on the graph, but how do you know in your operation that you're running rich without equipment to monitor excess O2? A few easy indicators of running combustion rich are smoke coming out of the exhaust, CO alarms going off, black soot covering the furnace, the rafters, and equipment, or in some situations, fire out of the exhaust. So if you see these conditions, it's very likely that your process is running below 1% excess oxygen.
right? And poor combustion can occur in radiant tube and open fire processes. The picture here on this graph, you can see a really good example of a radiant tube that's almost fully clogged with carbon soot. This is really just all unburnt fuel. So you've paid for energy and you've turned it into carbon soot, which is now clogging your process and making it continuously more inefficient as you run. Now, in this particular case, the PSNERGY team was called on site because ambient CO alarms were going off, and it was really an unsafe environment to continue running the furnace without getting it back into the proper air-fuel ratios.
So how does running combustion rich impact the business? The safety implications are obvious. Ambient CO is a major problem, and creating more emissions per ton goes against all of the corporate commitments for environmental improvements that most of our customers have made. From a quality perspective, the more these tubes clog, the more inefficient the process becomes, which means we're not getting the right amount of energy to the product. So this can cause temperature uniformity issues within the furnace and product quality issues. From a delivery or a productivity standpoint, making less energy with the same amount of fuel means that you may have to slow down the process to achieve the right material properties. And lastly, from a cost perspective, buying natural gas and turning it into soot instead of energy to produce the parts you get paid for is a problem, not to mention the impact this poor combustion has on reducing equipment life.
Right. So when you run a combustion process rich, we make more emissions, we risk quality failures, we ship less product, and we spend more cash doing it. So now that we covered what happens when we burn rich with too little excess oxygen, let's discuss the implications of burning lean or above, let's say 4% excess oxygen. So let's go back to our graph. And as you can see, as the excess oxygen increases from that industry standard target of 3%, the amount of heat output is on a steady decline and really drops off significantly. The same amount of gas is being burned, but because we're putting too much air into the mix, we're not achieving the same heat output.
Maybe you're seeing increased ramp cycles in your batch process, or maybe you aren't able to consistently reach zone temperatures in your continuous process. Those are simple indications that you may be running combustion lean. So you may be thinking, well, my furnace controller takes care of all of this, but really it doesn't. The controller only asks for heat or not based on temperature in the furnace, and temperature is dependent on combustion. So if you're running combustion too lean, you're burning the same amount of gas, but not getting the same amount of energy to your products. So to overcome this, your controller will continue to ask for more gas to make the energy needed to heat the product. And ultimately, furnace efficiency and productivity significantly decrease when combustion is running lean. So let's quantify that by looking at some data.
Right, so this is a great chart that was featured in Heat Treat Today's June issue. And this shows the impact of excess oxygen in combustion at various exhaust temperatures. In his research, John Clark from Helios Electric Corporation quantified the harsh effects of burning lean, and all of our empirical data, what we've seen in field applications, really supports this research. So take a look at the highlighted sections. Operating combustion at 5% excess oxygen is going to yield a 10% drop in heat output. If you go to 7% excess oxygen, your heat output drops by over 20%.
So essentially, you're paying for 100% heat output, but only getting 90%, 80%, or possibly even worse. The negative business implications of running combustion lean are super clear. You're producing less for the same cost, you're taking longer to produce the same amount, and you're using more energy, creating more emissions, and it's all for more cost.
Yeah, that's right, Taylor. And it's not uncommon for us to find burners operating at 0% and even as high as 10% excess oxygen. In either case, the financial impact of the business is really significant. So regardless of your monthly gas spend, and we have customers that are spending $400,000, even up to $1 million per month in gas on very large furnaces, wasting 10 to 20% of that spend monthly really adds up quickly. So think about wasting $100,000 a month and getting less output and poor quality and more emissions. And again, it really doesn't matter the size of the furnace or the size of the operation. The impact on your business is still very significant. So to wrap up, combustion performance is really not about, well, the furnace is running, it's hot, the flame looks right, or this is how we've always run this furnace. There really is an optimal way to run industrial furnaces, and there are very real safety, quality, delivery, and cost implications to the business when you operate with poor combustion. So combustion performance delivers furnace performance, and furnace performance delivers business performance.
Good combustion matters in very real and tangible ways to your business. And if you're seeing any of the signs that we discussed today of running rich or lean, feel free to give us a call. We can help you get your combustion performance and your business performance back on track.
Great. So if there are any questions, we'd be happy to go ahead and type them into the comments section. Great. I'm happy. I think we were very clear.
Well, thanks everyone for hopping on our live today. We really appreciate it.
And look for our next event in the series where we'll be talking more about combustion and how data can help you really understand how well or how poorly your combustion is running. Thanks, everyone.